welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic the structure of the atom and the periodic table. And we are going to look at the ion formation, and specifically, we are going to be discussing on cations. Previously, we talked about the discovery of the periodic table. We are also able to identify groups and periods of elements in the periodic table. Can go back and check that video. So for this lesson, we look at the definition of ions and specifically cations, and then you do some practice on the same. So ions are usually formed when atoms are unstable. So when we say that atoms are stable, we mean that they have the maximum possible electrons. Examples are when we have an electron with a maximum of 2 electrons in the outermost shell only, we have 2, 8, we have 2, 8, 8. These are three different elements, are said to be stable. They are stable because they have the maximum possible electrons in the outermost shell, as you can see. So any other atom that does not have this stability, it can be the duplet state, which is 2, or the octet state because they have 8 electrons in the outermost shell. Every other atom does not have this, is always trying to achieve this configuration. They can do so by either gaining electrons or losing electrons. So when an atom gains electrons, it forms an ion. So an ion is called a charged particle of an element. It is formed when an atom either loses electrons or gains electrons. So for example, if a neutral atom loses electrons, we shall say it forms a negative charge. If an atom gains, a positive charge, if an atom gains electrons, it forms a negative charge. So the net charge of a neutral atom is always 0, but gaining and losing causes the atom or the ion to either form a negative charge or a positive charge. This is independent with the number of electrons and protons in an atom. So for example, if an atom gains electron, you notice the number of electron increases, it becomes higher. That is the reason why that atom gains a distorting negative charge or the total negative charge because the number of electrons are more than the protons. Alternatively, if an atom loses electrons, you notice the number of protons will be higher than the number of electrons. So in turn, it gains a net positive charge. So when you are showing a charge in a chemical symbol, it is usually indicated as a superscript on the top side. So for example, we have an atom X. The charge is going to be located in this side because the mass number is located on top left and the atomic number on the lower left. So the charge is always indicated in this direction. There are usually two types of ions. We have the cations and we have the anions. So for this lesson, we are going to discuss on cations. So cations are the positively charged ions. This tells us there's more protons than electrons. So these are ions or the cations are usually formed when we lose electrons. That is the reason why the number of protons are higher than the number of electrons. So they're usually mostly metallic in nature. So most of the metal will always react by losing electrons. So example is magnesium. So when you look at the electron arrangement of magnesium, it's dependent on the atomic number of magnesium. Magnesium is atomic number 12. So the arrangement is going to be 2, 8, 2, And then magnesium is going to have 12 protons. It's going to have 12 electrons. And when it loses, you can see from the arrangement, the magnesium will lose 2 electrons. It is easier to lose 2 electrons than it is to gain 7 electrons. And we have said it forms part of the cations that behave by losing electrons. So the ion arrangement, or the arrangement after loss, is going to be 2.8. It forms an octet. You notice the 8 electrons in the outermost energy level. The number of protons will remain the same since they are not being changed in the nucleus, while the number of electrons will be changed because it has lost 2 electrons, so the number of electrons becomes 10. So 2 electrons have been lost. So you can see the protons are more than the electrons. So the net charge will have a charge of 2 plus. So if you were to write the formula, it is going to be magnesium with a 2 plus. This is how it would look like. So another way of presenting this is using dot and cross. So if we are to present the ion, we will start first of all. So we can start with the atom and then we go to the ion. So the atom we discussed in the previous video is that magnesium, we are going to put the first 2 electrons, and then in the second shell, you put the next 8 electrons. And then in the third shell, you're going to put the last 2 electrons. This is how we presented the neutral atom. So for the ion, our ion arrangement has changed. We only have 2 shells because you have already lost the 2 electrons in the outermost shell. So we are going to put our symbol inside, and then the first shell is going to have a maximum of 2 electrons. And then the second shell, which is our last shell, we do not have another, is going to have a maximum of 8 electrons. And then the uniqueness with the ion, we usually put brackets outside the dot and cross structure, and we put the charge, which is 2 plus. So this is how we present the magnesium ion. Let's do another example. Aluminium. So the electron arrangement of aluminium is going to be 2.8.3. The number of protons it has is 13. The number of electrons it has for a neutral atom is 13. Then what it does, it loses how many? 3 electrons. Because it is easier to lose 3 electrons than it is to gain 5 electrons. So after loss, the ion arrangement becomes 2.8. And then the number of protons will always remain the same since they are not being interfered with. Number of electrons will become 10. And the net charge now will become 3 positive since it has lost 3 electrons. So the formula is going to be aluminium 3 plus. So if you were to draw that dot and cross structure for the ion, it's going to be aluminium. So the first shell has 2 electrons. We can use dots in this case now. And the next shell has 8 electrons. And we said in an ion, you have to put the brackets at the end to show the charge, and we put a 3 plus at the end. So this is how we present aluminium. So we'll do one more. Sodium, the electronic arrangement of sodium is 2.8.1. It has 11 protons and 11 electrons in its neutral state. It usually reacts by losing 1 electron. So when it loses 1 electron, the new ionic arrangement becomes 2.8, and the number of protons do not change, but the number of electrons change to 10. So you can see we have more protons, so the net charge becomes positive. You don't have to write 1. So when you write the formula, it's going to be the symbol of sodium, which is Na, with a positive. So let's represent the ion in dots and cross. So sodium symbol, and then the first shell is going to take a maximum of 2. The second shell will take a maximum of 8. We don't have any other shell in the ion, and then we enclose this with a bracket and we put that charge at the end. Ion formation also can be represented in form of equation, so using chemical symbols. So for example, our first question was on magnesium. So you can see from the equation we're starting with magnesium in neutral state, it reacts by losing 2 electrons to form magnesium 2 plus. If we look at another example like sodium, the symbol for sodium in neutral state is sodium. It reacts by losing 1 electron. So the new formula for the ion will be sodium with a plus. If we look at calcium, which loses 2 electrons, is going to be calcium with a 2 plus. If we do aluminium, which loses 3 electrons, it's going to form aluminium 3 plus. So this is another way of forming the equation and showing the ion formation of these atoms. So let's do a few questions. So we are going to show the number of protons, electrons, neutrons, and draw the ionic configuration of the following ions. So first of all, the number of protons is 11 from the atomic number. The number of electrons is not the same as the number of protons because you can see 1 plus, it means it has lost 1 electron. So the number of electrons becomes 10. The number of neutrons also is not interfered with. That is going to be 12, and we get 12 by 23 minus 11. And then if we draw the ionic configuration, it's going to be 2.8 because initially it was 2.8.1. It lost this 1 electron to form 2.8. And if we were to draw the ionic configuration, it would be sodium on the nucleus, and then 2 electrons, and then the 8 electrons in the second shell, and finally the bracket, and a positive. Another example is lithium. So the number of protons for the lithium is going to be 3 because of the atomic number. And then the number of electrons is not going to be the same, the number of protons, because 1 plus tells us that it has lost 1 electron, so it becomes 2. And then the number of neutrons does not change. The number of neutrons is 4 because it is 7 minus 3. That is the mass number minus number of protons. And the ionic configuration becomes 2 because it's just 2 electrons left. So if we were to draw that, we would write lithium at the center and only with 1 energy level with 2 electrons, and then we enclose that in a shell and we write 1 plus or just plus. So you can do more practices on the 20 elements so that you can be able to see how their ions behave. So that was cations. So see you in the next lesson as we discuss on the anions.